All right. Also, very warm welcome from my side. My name is Yves, founder and managing partner of the Python Quants as well as of the AI Machine, our new company and project. I think now I'm taking the discussion a little bit higher in terms of like getting a bit more abstract in the sense of that. I'm pretty sure you have heard about the quote by Mark Andreessen who said, well, software is eating the world. But I think for us in our field, data is eating finance from my point of view. So I was growing up when I studied finance back in the days. I did my PhD in math finance. So it was all about theory, all about models. Then there came the computational phase where people started applying Monte Carlo simulation and heavy workload computations to the field. And now we have the data driven finance world. And this is one of the core topics of my talk here in this regard. And I think it fits pretty well to what we have seen so far. So maybe a little bit more of an, as I said before, abstract perspective, what to do with all the capabilities that we have seen with regard to the Icon Data API. A quick introduction, I prepared a couple of slides to see, probably kind of read it pretty well, but we can share this later on my slides I hosted online, so you have access to all the resources that I'm going to show. All what we do is centered around Python for finance. We run events, do trainings, written books, we run a platform, so providing commissioning Jupyter notebooks is what we do for 20,000 people plus. So it's a pretty interesting approach, I guess, because shuffling data around the net is really inefficient from my point of view. To bring the compute to the data, this is what people do in high performance computing since years or even decades. And I think this is also the right approach to get the compute to the data instead of like sending data around the world thousands of times for the same data sets, right? So what we do, again, Python for finance, many topics around that, but our core is Python for finance and lots of machine learning, AI, and algo trading these days. Our flagship offering is our certificate program, which offers quite a lot for those who want to apply Python to trading and to other fields in finance. We have like the sister program as well for computational finance for those who are still involved with like option pricing and like the quick world, the rocket science, and the financial engineering part. This is a project I can demo you quickly. Afterwards is our way to walk the talk, to trade based on what we preach and what we teach. So I will give you a quick demo, quick overview later on. Here the 1 minute or 5 minute read maybe about what we do. So feel free to follow all the links that you find there. About myself, here you'll find all my talk resources, not that much about my person or the family or my hobbies or whatever. It's all about Python for finance as well, like videos, podcasts, slides, gists, GitHub repos, whatever I've ever prepared for my talks. My books, the middle one, the best-selling one, so Python for Finance, pretty happy that this has become kind of a standard reference. It's used not only by practitioners these days, used by many universities and lectures. I know here in Frankfurt as well. I was invited once here to give a guest lecture where, the professor used the book as well as one of the major materials. I'm pretty happy. It's around the world. It's used, Asia, left-hand side. Just after this talk, I will meet an O'Reilly editor who's responsible for the Japanese translation. Was translated in Chinese as well. So Python for finance, I'm pretty happy. I started with it 15 years ago, but now it's a global phenomenon, and I'm pretty happy to have been part of that. We run communities, among others, with support of Refinitiv as venue sponsors, for example, in London as well as in New York, but a few more. Also one in Frankfurt, which is not that active, I must confess, but maybe more in the future. So coming to my topic, powered algo trading. AI success stories. This will just be a minute or two just to review maybe stories that you all are aware of. Then the beauty myth in the context of finance, what data-driven finance brings in the form of Icon Data API and all the things, the nice stuff that we have seen already today. Then what we are up against in algo trading, the efficient market hypothesis. If we can't beat it, then there is no alpha to generate. And then I want to argue that AI might help here and there a bit. I will also then have demos to, or in the context of deep learning and the AI machine, I will conclude. So I tried to speed up a bit because the talk was designed to be a bit longer. So let me get started immediately with the topics. AI success stories. I'm old enough to recall when Atari 2600 came out, and it was fantastic for me to observe that DeepMind managed to train via self-reinforcement learning a machine in a general sense. So when I say machine, it's the combination of hardware, software crunching data to be better as human level players for like most of the popular machines back then. But what was fantastic is that the approach is not only applicable to such games, but also to other games, such as the game of Go, where people in 2014, just 1 year after the success story with the Atari games, still like the experts in the field said, well, Go seems to be a pretty hard nut to crack. It might take another decade until the machines become better than the world champion. And we all know the story. 2015, the European champion was beaten. 2016, the world champion was beaten. And it wasn't kind of like that Alpha Go was kind of the final step for DeepMind. They added and got better and better, different iterations, Alpha Go Master and then Alpha Zero. And I think Alpha Zero is really kind of fantastic that I said, well, this approach is not only applicable, obviously, to the game of Go, we can apply this to other fields as well. Other fields, namely chess. I have some relationship to chess. I'm not a good chess player, but kind of like intrigued by the stories, the people, and the history. Also computer chess. We have a look back. In the 80s, nobody expected the machines to beat human grandmaster level players anytime soon. Then it took like 12 years longer after the first story mentioned here in the book by Garry Kasparov, back then the world champion, that he was beaten by a big machine. But this machine, although it's mentioned quite often in the context of artificial intelligence, was really like a powerful brute force based chess engine, right? That designed specific chips to be fast at playing chess. Not as kind of like intelligent, but fast, right? And today, everybody can take out their smartphones, and every kind of chess program available is better than the current world champion. So it's fantastic how far we have come. But my major point, and really intrigued me with regard to deep learning, what can be done, is that Alpha Zero, like the latest iteration from the Go story, actually was able to master chess within, let's say approximately 9 hours of training. Only 9 hours. So when IBM was able to beat the world champion with Deep Blue, and today we have all these still traditional chess engines like Stockfish, they rely on decades and decades of research and of human master level input in that sense. But this machine started out from scratch, playing against itself, and simply based on the rules, they were of course codified, you need to know the rules of a game, was able to master the game within 9 hours. And this is kind of, for me, the major breakthrough there. And it's like this general idea of learning different games, and this obviously can be translated to other fields as well. Where are we now in finance? I mean, everybody is talking about finance and AI in the field machine learning, and in many areas it's kind of like probably successfully applied these days. But to a large extent still, and I have many of these books on my shelf, we have theories in the financial textbooks that are similar to the physics textbooks mentioned here, that contain nice theories, elegant theories where people fell in love with a while ago, but where there's hardly any empirical evidence. So they don't stand the test of time in the sense of that, well, whenever put to rigorous tests, let's name it capital asset pricing model and all of the famous theories there, they hardly have any empirical support, nor in that sense, of course, practical use. But I was intrigued back then when I studied this for the first time. I came up then with a proof that I somehow mastered and was happy. So, but the beauty myth is still there, and although this is about physics and finance, is the same thing. So some of the theories that are nice but not really useful are expected utility theory, equilibrium considerations. Then we have the major assumptions there, normal distributions and linear relationships. So hardly anything, almost nothing in finance is normally distributed, nor are the relationships in general linear. And those corners of our field that have been successful, like arbitrage pricing, they simply took into account that there are asymmetric, nonlinear relationships and applied different approaches. And these have proven to be useful, others not. And unfortunately, in algo trading, the efficient markets hypothesis or random walk hypothesis is something that has stood the test of time. So there's lots of empirical support, and this simply says that doing research doesn't make any sense, right? It's not worth the while. theory on the left-hand side, normal distribution, reality, and this is real data. I don't recall which, maybe some Apple stock, technology stock. You see the fat tails there on the QQ plot. This is reality, but theory still assumes that, and we all know that fat tails obviously are important if we talk about investment performance and success. Linear relationships all over the place. One of the most famous linear relationship, the beta one here, embodied by the capital asset pricing model. Only market risk is relevant for the rest not. So, of course, I mean, this has all its origin in the 60s, but we are 50 years later, right? So that's the problem. Now, what do we do with the data-driven world? We have now all the data available. Back then, it was kind of like difficult. We needed kind of like brilliant professors that said, well, pen and paper, nice equation, here's a mathematical proof. Now we have the data available. How do times change? So when we have a look, of course, we all read the newspaper. So I have one article open here, which fits very well to the context here, the Financial Times from today. So I read it usually on whatever device. I'm just here. And this fits very well to my story here. This is from 8 hours ago, from this morning, the article. Why hedge fund managers are happy to let the machines take over. Some claim computers are getting better at finding profitable patterns in market data. And that's what the whole story is about. Finding patterns on which you can trade and which you can economically benefit from, which means not only statistics are relevant, but also whether you can exploit something that you identify in the markets profitably. This is a second part of the same story, but a very important one. I mean, you can have any edge if you're not able to benefit from it. It stays something hypothetical, right? So this is what we have. We still read it, I read it, but they are more or less articles only about what is happening. It's not kind of like driving the markets anymore. What drives the markets? People having a look at data, having a look at the Icon terminal. Today we almost exclusively saw kind of the API, and this is where we have arrived. So most of the things in the markets are driven by what machines are processing. Here you see tick data for Apple, 1 hour, 28th of June this year, 20,000 tick data points. When you think back, Apple went public roughly 40 years ago, 1980. 40 years make for some 10,000 end-of-day values, right? So the end-of-day theoretical underpinnings, 10,000 data points, and here we have within 1 hour 20,000 data points. So there's no comparable theory to the CAPM world, etc., that we have here for our new world, actually. So therefore, people rely on other things like data processing. And I like to say that for the machine, it doesn't matter whether it's like 2,000, 20,000, 200 million data points. Modern machines, particularly when you put it in the cloud or proper server infrastructure, it's not a big deal. But it's not only, and we have also seen quite a few examples in this regard, that numerical data is the domain of machines. Today, the machines are reading the news as well, and much, much faster. So roughly 1.5 million articles on a daily basis are digested by the likes of Refinitiv, and they are available in programmatic fashion. Of course, nobody wants to read through all the articles that might be potentially relevant for what you're up for in finance. Holds true for trading, investing, for risk management, for kind of like everything. But the machines, they can do it in the same way, and they're getting better and better at interpreting and judging what is kind of like in the article, whether it's important or not, what the sentiment is, etc. And this can all be done in real time, basically. So the machines can do that. And why is it so important? Because the availability of big data has proven so useful in so many other fields. Here's a widely cited article, The Unreasonable Effectiveness of Data. And for example, natural language processing is one of the fields that has benefited tremendously by the availability of course, lots of data in the form of web pages of whatever kind, and the increased compute and data processing power that the big ones like the Googles, Facebooks, etc. have available. Maybe finance is more or closer to natural language than it might be to a real science like physics. So here, physics envy is what is mentioned there in the sense of that physics has so many concise, powerful, short equations, but maybe finance, economics in general is not the field that is kind of like to be captured by simple formulas like the CAPM that we saw before. It might be that just the big data availability will see or give us breakthroughs. Python, of course, I'm a Python guy. helps us with all the needs, all the requirements that we have, and it's already quite a bunch of interesting applications there. So what are we up for now in efficient markets? Efficient markets, of course, pose a problem to anyone who wants to benefit from trading in the markets, right? So here the seminal article by Eugene Farmer, which basically says if the market follows around the walk, then any kind of analysis like technical charts, procedures for predicting stock prices are completely without value. Because if the current price embodies, signals every information that's available, and we have like the weak form, the semi-strong, the strong form of market efficiency, no matter what you take. So I'm usually concerned with the price, time series efficiency, the weak form. Doesn't make sense to go back and do charting or technical analysis or whatnot. If you put it a little bit more modern, I like to cite here Jensen from the 70s. The market is efficient with respect to an information set S, how large it is, whatever it is, if it is impossible to make economic profits by trading on the basis of information set S. And important here is economic profits, because again, you might see some statistical edge someplace, but you need to be able to implement a trading strategy that in the end exploits the opportunity profitably. And to put it in an operational way, we would say in such a case, the best predictor of tomorrow's stock price in the least square sense is today's stock price. So now AI first finance, what might finance bring to the table? And again, a quick look here. Machine. Some claim computers are getting better at finding profitable patterns in market data. So that's exactly the story this morning in the Financial Times. And we know machine learning algorithms are pretty good at learning about patterns and, making decisions based about patterns. Why is that? Because scientific method, here you see a quote from the web, courtesy of the web, means that researchers come up with a hypothesis, they formulate it, they test it, maybe they refine it, modify it, but every researcher, no matter how productive, only has 24 hours, 7 days a week, and there must be some sleep and some food as well in between. And the machines now, and machine learning in particular, is what Pedro Domingos in his popular book calls the scientific method on steroids. It follows the same process as the regular scientific methods, but while a scientist may spend his or her whole life coming up with a few, I would say a few, proper hypotheses, the machine can come up with thousands and thousands within seconds. Test, refine, and there is no ego involved in the machine. It's not kind of like, I have published that, this was my idea. No, the machine says simply, well, when the data speaks a different language, the machine simply changes opinion, right? Hypotheses are adjusted within seconds or even milliseconds. And speaking of patterns, you recall, like, again, the FT article from this morning in spotting patterns in the markets. And this is what traders do since years, decades, try to see patterns based on which they can maybe profit from the market. So here 20 patterns, but for sure for a machine, it's not only these 20 patterns, and it's not about to teach the machine the patterns. The machine should learn the patterns itself. So maybe different ones, maybe selecting from 500,000 the best 5 ones or whatnot. But we as human beings, I'm pretty sure nobody of us can ever like master, see, check, learn about 100,000 patterns. But the machine doesn't really care. So using, of course, probability and other statistical methods, the machine can come up with probability estimates for hundreds of thousands of different patterns. So in that sense, it's fantastic. We don't need to come up with the rules, put the data to it, and then wait for the output. The machine, when fed supervised learning, of course, this is here. We feed it the input, the pattern, and the output, what happens afterwards, and the machine comes up with the rules and the trading pattern. That's a fine thing. So we just have the data, data-driven finance. Input and output is the data, and the machine comes up with the code, comes up with the software in the end. And for finance itself, overall, putting it all together, this means, of course, markets are complex. They process the ever-increasing volumes, variety, velocity of the data instantly, in real time, but this in a non-linear, complex, changing fashion. No normal distributions, no linear relationships, and no stable relationships, even over time. And the history was driven by like the simple equations that I like and so many others like, but that have hardly proven to be of any value if you want to profit in the markets. And Now we have the data available. That's kind of like the prerequisite. Data has become the oil, as many people say, for our industry. We have the powerful algorithms. So many progress has been made in the field, hardware side, software side, on the numerical side. And if we are able to apply them profitably, then we might gain some edge here. Again, the machines, that's the subheader of the article that I was showing you, are getting better. I also think that the people applying the algorithms and steering the machines are getting better and more used to this field there. There are books out there now. This was one of the first, combining finance with machine learning. Many, many more have been published afterwards. So this is from, I think, January 2018, one of the first, or if not the first, book on the topic. Python, again, first-class citizen in this field, not only due to finance, but due to the other industries. Maybe some additional hardware might be required, but you can get started with proper, simple hardware. So I've prepared a few demos. I want to quickly walk you through these demos. I have like static ones in order to save some time. Maybe just the efficient market hypothesis. So everything that I'm going to show you is based on data that is retrieved originally from the Icon data API. Here with regard to the random walk hypothesis, I first get started. There's just some technical stuff with the versions. By the way, there are like Python tutorials. This is based, for example, on a Python tutorial that is available on the developer portal, for example.
There's a series of 13 video tutorials with the accompanying notebooks there.
And here I'm retrieving cross-asset data, end of day, simple stuff. We see here the data frame, the beginning and the end, so to say, is a couple of years worth of data. A total of 1193 data points. Of course, this is small data, but for a verification, a little analysis with regard to the efficient market hypothesis is not a big deal. So calculating the returns, maybe having a look at the data. So you see I tried to come up with a bunch of time series where one is performing pretty well. Here I think this Apple, the other one is not so performing well, the GE stock, and then we have mean reverting quantities, like this purple one is the VIX volatility index, and we have some that evolve here in the middle ground. So this is, of course, all normalized there, right? Histogram of the returns. So you see here, for example, Bitcoin. Immediately, this is not normally distributed. This is not normally. They can basically say for everything that we see there are no normally distributed returns, but this is not my major story yet. Correlation matrix. And what I want to do here to get some support, I said before, this is how to make the efficient market hypothesis operational, is that we say, well, in a least square sense, the best predictor for tomorrow's price is today's price. So if this is the case, then we have efficient market. And we say, well, all the information is here, right? So I don't need to look back in history and try to analyze some patterns. I have a look at today's price, and basically there is no value in doing some analysis to come up with an estimate for tomorrow's price, whether it would go up or down. That's the basic formalization of the efficient market hypothesis that I'm following here. So I work with price lags. So I simply lag my data. Simple approach here, 7 lags, but you can do it with 3 lags, 17 lags, or 70 lags. The major or the basic insights won't change. So I have here for Apple, for example, this is like today's price, and this is yesterday's price, and 2 days before, 3 days before, 4 days, 5, 6, 7 days. So 7 lags, like whatever the price formation might be. And to this lag data, for all my names, I'm applying ordinary least squares regression, pretty straightforward. Going here over the RICs in my data set, and what we see here is that indeed the lag number 1 here gets all the weight, and all the others have basically a weight of 0. So this means that lag 1 is the best suited to predict the price of tomorrow. All the others are more or less negligible. So just here you see kind of like the little exercise. The visualization, the prediction line here is basically the original one shifted by 1 day. So it simply takes the day price and shifts it to the next day. Always 1 day forward. Not to 100% exactly, but the numbers are pretty close. And speaking of the numbers, when we analyze the results, don't want to bore you with the with the columns of numbers here, see the visualization, and you see that the regression parameters for lag 1 are all close to 1. Pretty close to 1, sometimes even exactly 1, and that from lag 2 onwards, there's hardly any weight for the lag in terms of predicting it. These are, I would say, numerical inaccuracies or simply differences given the noise in the data. And these are the average values which make the point even better. So 0.977 roughly for lag 1, and the rest all pretty close to 0. So efficient markets, I think here we have some support to it with this little analysis. End of day, but of course when we talk about algo trading, most people have something like intraday in mind. Maybe not high frequency necessarily, but intraday, indeed, the picture is slightly different. So my regression parameters are different. So for the SPX, I think this is a highly efficient instrument. It reflects or approximates the American stock market. We see kind of the results from before. So just like last minute's price, this is now minute bar data that I'm using from the Icon Data API. This has a 1 and the rest is kind of negligible. For single name stocks here for currency, and in particular for Bitcoin, you can see that the story here is different. So maybe in Bitcoin there might be intraday formations that we can exploit. So end of day markets seem to be pretty efficient, we can say. Maybe not as efficient intraday that we can say. The question is, how can we benefit from that? That we say, well, intraday, yeah, let's have a look. I have another notebook there, another one that I've similar to what I've been showing yesterday in Paris, but I changed it to deep learning. It's now based on deep learning. The data that I use now for the analysis here with machine learning, so the title here is discovering statistical inefficiencies via deep learning. The data that I work with is exactly the same. So I'm just replacing my ordinarily scarce regression by machine learning, by deep learning approaches, and I add, this is happening down here, I add more features, like typical technical features, in the sense of patterns, meaning simple moving average, minimum, maximum, momentum, volatility, simple stuff, just like 20 days or 20 minutes, actually. And I lack all the features. So I'm adding now more information to the story. Here in machine learning, we call this then feature, right? 7 lags is what I use, and then I apply bagging here. I use here the MLP. There's a multi-layer perceptron classifier, deep neural network connected, fully connected neural network with 2 times 256 units. 2 layers are 256 units, and then, as before, I go over the data rig by rig. I train the model here, model fit. I train the model. Every time I create a new model, I train the model, I do the prediction, I calculate the accuracy. And what I do here is a little bit different from what I've been doing before. Before it was an estimation, a regression exercise. I tried to regress to estimate next day's price. Now I'm changing the story a little bit to like whether the market goes up or down. So I train it in a binary fashion. So my label is not like some floating point numbers anymore. My label is just the direction, market going up and down. If I'm trading, if I want to do algo trading, this is kind of like the first thing, and it simplifies things indeed. And when we see here in sample, I'm happy tonight I will be in Baden-Baden and we go to the casino there. So when you think in terms of roulette, black, red, 50-50, and this will be our baseline as well. So when the random walk hypothesis holds true, then there is a 50-50 chance whether the market goes up or down, if it's a random walk. And the same would hold true here for our stocks, for whatever we are analyzing across asset, but the edge that I get in sample, this is like the important thing, is like 60% upward. So if I would have an edge tonight in Baden-Baden of 60%, red and black, I would be, at the end of the night, most probably a rich person. So this would be excellent. But in sample is simple. This is like having a look at the history at the table and seeing what were like the recent draws, and then learn, infer from that, and repeat what was there. So that's the simple case. This is not interesting. What we want to do, and this is like the next little exercise, We want to train the model on a certain part of the data set. Or here I take the first 70% of my data set and train it, and then I test it on the remaining 30%. That's interesting. So I observe roulette table drawings, and then I learn something, and then I start playing anew. So without having information. This is what I do here. And then suddenly you see, oh my goodness, well, apart from the VIX, where we see some significant deviation from 50%, euro slight edge maybe, but the rest either below 50% accuracy, even here for Bitcoin, or slightly above, where it's questionable whether there's any kind of strategy where which we could economically benefit from this strategy. But our hope was intraday, so a friend for trading, and with the intraday data, same data as before, same approach. Now I skip like the in-sample side of things because this was just for illustration. Before is not relevant. Oh, here, take 80%, could have taken the same thing. Intraday, we indeed see some edge there. Not for every instrument, but for GE, looks good, but not for Apple. So we cannot say really for every stock this seems to work. The VIX, similar as before, so VIX seems to be kind of predictable, but it's relatively expensive and not as simple to benefit from VIX prediction of V-stocks in Europe, for example. Here we have a slight edge, but the euro, yes, this is what we focus on. We personally, with the AI machine, with our project, we focus on Forex trading. So there might be something in it in terms of like having an edge with regard to the prediction. And BTC intraday here looks also pretty. Again, these are out of sample numbers, not like the in-sample one. So I trained the model on the first 80% and I tested here on the second percent. So we have the data available. We have the algorithms available. We have the hardware available. We have the complete logistics infrastructure available. And as you might have noticed, there's no finance at all in the whole analysis, right? I'm talking about finance, about markets might be moving, but there's no finance in there. So I don't need, and nobody needs kind of like a finance textbook with any kind of theory to come up with that stuff, right? We have general algorithms that we apply to the data that we have available. But again, this is about statistics. I again want to emphasize this point, but we need to be able to beneficially exploit that. And this is then the story. Oh, I was logged out here. I'm still on the web. Let me log into the AI machine because I started exactly this strategy on a 1 minute bar so that we see quite a bit. Because the analysis here, this is not too difficult, and if you have a little bit of Python experience, you can learn that, for example, with our programs. And I started a strategy, I don't know, 1.5 hours ago. And usually we don't focus on the 1 minute bar level because you might be eaten up by transaction costs. Here, this strategy just started. Let me have a look at it. This morning, this is here GMT time, so this is running UK-based server, so this was started at 10. Now we have like this 1.5 hours. That's so small. Yeah, I must have a look here because on my notebook it's so small with the thing. But I'd say not more than 2 hours. And exactly what I was showing you in terms of research, this is what is live trading here. So to show you the whole process, this is the bagging one. I use the bagging classifier, but I think I'm now trading with a decision tree. There is the Python code. So this has some. Here you see the feature preparation. Actually, the same features that I've shown you in the little Jupyter notebook. And there's a total of 187 lines of code, and that's all the Python that you need in order to define your strategy. And then the next step is that you can backtest the strategy here. The first one is the backtest that I started. Oh no, I didn't want to open. The thing that I'm trading is that one. So you see, I initiated this morning. That's the strategy that I backtested. Here you see the backtest results. You can analyze them in detail here as well. You can also export it and have a closer look. And when you say, well, yeah, this is my code, the strategy looks like backtested in Jupyter Notebook or wherever, then you simply say here with this strategy, what I did 2 hours ago, go live. Quantity to trade, stop loss, trading stop loss, take profit, whatever you want to specify here, profit capture stuff, hedge parameters. down here, and then you click Add Model, and this is what I did. But when I would do it now, it would need to wait quite a bit until you see the results. When I get back to my live model, you see realized profit is now 1.84%. This is in percent here. Unrealized currently, the current position is negative, so we have a loss currently. And here you see the whole trading history, the short position. Whenever you see here a PO, this is position offload, so we have many rules in place. So we say, well, the first 50% of the position is closed when we reach the first target level. Here PC means profit capture. When we have the position offload, then the trading stop loss is adjusted, and you see here the signals. There were multiple wrong signals, but we didn't lose any money anymore because the trailing stop loss is kind of adjusted in a way that we won't lose any money anymore. So you see green ones are the correct signals, the red ones are the wrong ones, and so it's now trading. So in that sense, what they say here, some claim computers are getting better at finding profitable patterns. That's the first part. This is the back testing that I was showing you the notebook and on the platform. But the difficult part for everybody involved, and I can only recommend that you read the text because there are also valuable links to studies, like a recent study about machine learning and finance, in there that the difficult part is to get this up and running and trading. That's the difficult part. 180 lines of code for the strategy, but maybe, I don't know, 30,000 lines of code to properly deploy it. And data is what fuels that. There is no finance anymore. Data is eating finance these days. We have general algorithms. They work pretty well in many instances, and the AI machine, see here, I showed you all that, what is involved there. We take care of the features, labels, machine learning, backtesting, and the deployment in that regard. You saw this live. And the difficult part indeed is, and that's the reason why I'm emphasizing the statistical inefficiency from the economic one, is that the predictions are cheap in a certain sense. But you need to make sure whenever you trade, act in the markets based on your predictions that they are proper decisions. Just think of a self-driving car, and the signal is to go to the left, to take a left turn. But there must be security checks in place. If there is another car, if there are pedestrians on the street, you probably shouldn't take the left turn right now. You should put on the brake and stop there. And this is how I see our decision rules and all the capital management approaches, etc., what is required. And then you have the technical problems, like to have this up and running 24/7 with everything done in real time. But Icon Data API, you saw the streaming ones, the news streaming, the tick data streaming, etc. This is where you get the information from in order to implement this profitably. So from my point of view, software, again, is not only eating the world, data is eating finance as well. In the summary, beauty myth is what was, from my point of view, driving finance for a long time. Now we have big financial data available, and not only that it's available in principle, you have the APIs, you have the code, you have the packages, you have the infrastructure to process it. And now that you have the big data available, the finance theory doesn't play that much of a role anymore in many areas. Not in every area, many areas. And I think AI has changed many fields forever. And for finance, the combination of lots of data, for example, via the Icon Data API, and applying the algorithms and the compute power available for today will change our field for good as well. Thank you.
Right. If anybody has any questions, take a couple of questions. What we're going to do now, if you have any questions for Eve, we run a bit late now. We'd just like you to fill out these questions, this survey, and then if you fill out the survey, hand it in at the front desk, you'll get a t-shirt like this in your size. So I'm going to start passing around these surveys, and feel free to ask Eve any questions.
Are there any questions?
Yes.
Yes.
Maybe some feedback on the tutorial series. They were really helpful. So I used them to when I started programming with Icon. So thanks a lot for them.
Glad to hear. These are the ones I need to hear that. Great, love to hear that. Yeah. Anything we could improve upon there? The tutorial series, how did you like the format, like the length of them? We kept them intentionally short.
Yeah, I think length is important.
Yeah.
It could be longer.
Could be
Yeah,
longer.
it could be longer. Yeah.
Yeah, well, I have like, with our program that I shown you, there are like 200 hours of instruction available. So we would have enough, but we thought that most of the people who are interested have the programming background and just want to get started. So this was the quick start tutorial idea. Any other questions? Or writing, waiting for lunch?